Okay, welcome to part 3. We've taken the screws out so we can take a look inside, and we can explain some of these other buttons before we go into the schematic. But here we have the cow sign button. So basically, if you go to calibration, and inside we can see our 555 generator here. So in calibration, it allows you a square wave on the scope, so you can adjust these two resistors so that you get a nice 1 kilohertz square wave. So then when we go back to sine, it's not the greatest of all sine waves, but it kind of evens out the sine wave, and we can see if we go to measure, we can see that we've set it to 1 kilohertz. So that's what the cow button is for. The other button down here is the ISO sig. ISO sig, the only thing that does is isolate the outputs or connect up the signal generator. So if we go back to sine, come up here, we have our sine wave. If we go ISO, it disconnects the generator from the output port so you can do other tests. So there's signal, and there's ISO. All right, so inside the unit, take a quick look. We have our 555 generator. We have our sine wave generation portion of it. So the square wave just feeds into this. These resistors, these capacitors make the sine wave. We have our 100 ohm precision resistor. We have our LM386 module here. Our switches, our LED right here, and our output jacks. So that's all there is to it. The case is rather simple if you look at it. It's just these 3 pieces of wood glued together with some outside pieces and some legs put on the bottom. So it makes a real simple case, but it's easy to make. So, and it's very strong because everything's glued. All these pieces are glued together. Had to drill out a section so that the amplifier could fit down into it. But once you put it together, it makes a nice unit. So that's the function of that. ISO sig isolates these jacks from the signal generator, sine cal, square wave so you can calibrate it. That's all. So one thing you want to do when you set these jacks up is you want to set them just far enough apart so you can get one of these type adapters in, and that will make hooking up a multimeter much easier because you have one cable. So there we're hooked up, and there we see the voltage. So if you have these type of connectors, you can use them back and forth on a thing. All right, so I'm going to go ahead and put this back together, and we'll go through the schematic. Okay, so here's our schematic. We have a 9-volt input coming in here. Comes into the on-off switch. That's self-explanatory. That goes up, puts power to the diode. Diode turns on through this 270 ohm resistor to ground. The power also goes to the 555 timer module and comes over here to the LM386 module. So we turn the 555 timer on. It puts the square wave output out, and here's that cal signal we're talking about. So in cal, the square wave signal is picked up before this forming network, goes to cal, comes out of cal, goes through a 390K resistor to the module, and then out here through the 100 ohm resistor, comes up to the signal jack, and then goes out to the A, B, and C. So let's go through that again. And Cal comes through here, down through the 390K resistor, up into the LM386, out through the 100 ohm resistor, back up through SIG, out to the B and C. In sine wave, this square wave signal comes in here, goes through this resistor capacitor network, this resistor capacitor network, this resistor capacitor network, and comes out as a pseudo sine wave. So then it goes up and through the sine wave switch to the 390K, which the reason this was put in it was because the signal was too large for the LM386 and it would distort. So this 390K resistor was to drop down distortion. So it goes in there, again, comes out of the LM386 module as a sine wave, through our 100 ohm resistor, and out the output jacks. The last thing is the ISO. So basically, ISO just disconnects the signal. So the signal is disconnected. So these jacks are apparently open with the exception of this ground. But you can do the test with that. You can put a signal in here and it's isolated from all this. And that's all there is to it.